In this tutorial, we will learn how to compute descriptive statistics in R. So to get started, let's make sure that we have the RStudio program open. Next, let's open a new R script file by going to File, New File, R script. And let's save as to save this new R script file, which is our R script editor. And I'm going to call this test. And I'll override an existing file there. Okay, so this is all about descriptive statistics in R. So it's a bit beyond the scope of this tutorial to describe the different measurement scales, whether they be nominal, ordinal, interval, or ratio in nature, but I'll be using that language throughout this tutorial, and largely speaking, I'll be focusing on categorical versus continuous variables, which those can be kind of wrapped up into. And so if you please seek other sources if you want to understand more about measurement scales. Okay, so the first thing that I would like to do is set my working directory. So using the setwd function from base R and noting that my working directory folder is R workshop, make sure I get the capitalization right. I'm going to set this by running this, and you could do the same thing wherever your data are saved by going to Session, Set Working Directory, Choose Directory. Now, what data am I referring to? Well, that R workshop folder has this data set in it, or data file, which is called Employee Survey Example, with a capital E, capital S, and capital E, no spaces. I'm going to copy that so I get that exactly right, because the next thing I want to do now that I've told R what the working directory is, where that data file is located, is I want to read in the data. And so let's call these data just survey data. Well, this is what we'll name our data frame object, survey data. You could call it whatever you like. I use the left-handed arrow to note that I'm providing the new name to the object to the left of the arrow. And I would like to use the read underscore CSV function that comes from the reader package, which is part of the tidyverse universe of packages. And here is where, in quotation marks, as the argument for the read underscore CSV function, I need to type in employee survey example. This is something I previously copied, and now I'm pasting it in. And make sure you add that .csv extension there to the file name. Now, before I can use this, though, I need to make sure that I've installed and accessed the reader package where the read underscore CSV function comes from. I've recently installed this. I won't run that line that I just wrote there, but I do need to run library and reader. So the library function with reader as the argument to say that I need to access that reader package so I can look at and use this read underscore CSV function here. So let's go ahead and now run this line right here. Click run. And so let's take a look at this new data frame object that we've called survey data. Okay, so this is survey data. So we have a unique identifier of survey IDs here and let's assume that each row represents a unique survey. So one employee who completed it. These are the different items for the job satisfaction measure and so forth. And then we have some demographic information at the end. So we have gender, man, woman here, the different levels for gender. We have age, tenure in years, let's say that's organizational tenure, and then we have location where the employee works. This is all self-reported here. And note that the first letter in each of these variables is capitalized. So that's really important there. Okay, so now the next thing that we need to do is let's assume that we look through the data here and we want to describe the data, but in order to describe the data, know what type of analysis to run to describe the data or what type of data visualization to create, we need to identify its measurement scale. And so first off, gender, this is defined here in this data frame. We operationally define this variable as being man and woman. So gender identities of man and woman here. So there's two levels here that were self-reported in this particular organization. And so this is going to be a great example of a nominal or categorical variable because the two levels, they don't have an order to them. I mean, you could order them alphabetically or reverse alphabetical, but they don't have inherent numeric properties. So they are by definition categorical or nominal in nature. Whereas if we look at, technically speaking, these different items for the surveys, these are going to be more ordinal in nature. Let's assume that one is equal to strongly disagree with a statement. 5 is equal to strongly agree with a statement. So maybe job sat 1, what people were responding to was, in general, I'm satisfied with my job, strongly disagree to agree, a 5-point scale. So although sometimes we often will treat these in the social sciences and HR as a relatively continuous variable that we pretend like it's on interval measurement scale, technically we don't know what the intervals are between these and whether they're equal. So the difference between 3 and 4 versus 2 and 3 and so forth, whether those are equal. So, but we usually relax that assumption when we're doing this. So let's pretend that let's first work with an ordinal variable. Let's use job sat 1 as an example. And then our nominal or categorical variable is going to be gender here. So let's start with our nominal / categorical here and ordinal measurement scale variables here. And so if we want to describe those using a particular type of analysis, a count or a frequency is going to be most appropriate here. And so if you haven't already, make sure that you install the dplyr package, which is also part of that tidyverse universe of packages that's great for data science and data management. And so be sure that you install that. I've recently installed that, so I'm good to go here. I won't run that line of script, but I do need to use that library function as we did with the reader function again, as we did with the reader package above. I need to use the library function and use dplyr as the sole argument to access that package. So let's go ahead and run that line of script there. So dplyr is now is activated, and now we can use the count function from dplyr to assess the frequencies or the counts for some of the variables that we're interested in here. And specifically, we're going to look at gender and the job sat 1 variable. So let's start with gender here. Okay, so I'm going to specify this without pipes here. And so what that means is I just will put the name of the data frame object here, so survey data, as our first argument. Okay, so this is the name of the data frame object. And then I'll put gender, and it needs to be exactly as how is written here. So gender with a capital G, and click run. And so here we can see down in our output that we do have 2 levels to the gender variable, man and woman. So 85 men, 68 women, and then we have 3 NAs, so people that did not provide this here. Okay, so this is one way we can describe a categorical variable like that. Now, let's say that we also want to describe an ordinal variable, and specifically, let's do that. So typing in the same script, count is our function, survey data is our first argument here, and then the job sat 1 variable, which is that job satisfaction variable, and that was on that 1 to 5 Likert type scale from 1 equals strongly disagree to 5 equals strongly agree. And let's run that line here. Okay, so here we don't have any missing data. You don't see any NAs here. And it's kind of interesting. You can start to approximate what looks like a normal distribution in terms of the scores here. So if you're thinking of this as a continuous variable, as is often the case with Likert type scales, in terms of how we treat them in statistical analysis, you do see that most people respond in the mid-range, which let's assume a 3 is equal to neither disagree nor agree. 3 people strongly disagreed with the statement, 5 strongly agreed. Okay, so we could also, if you want, you can apply the count function such that you have multiple variables that you can enter at once. So let's say that we want to look at count where it's gender by that location variable. So we have the facilities. So here at the end, the location is Seattle, Boise, Portland, etc. And so all we do is add a third argument here. So name of the data frame and the 2 variables. So let's go ahead and click run. And here we see that now we have gender. And then so within the man level of gender, we have the different locations here and the number of people. Now, probably if you're really wanted to look at a nicer table, and this is what you're interested in, is looking more at like the cross tabulations of these, you could use the crosstabs function that comes with base R. So you don't need a particular package for this. And first you would enter the tilde and then the names of the 2 variables. So gender and then the plus sign and then location, the name of the second variable. So that's your first argument here before the comma. And then the next thing you need to do is specify what your data frame is equal to. And so here the data frame is going to be equal to what we named it initially, which was survey data. So both of these variables belong to that. So let's go ahead and click run and run that line. And so here we have what's maybe a little bit more user-friendly version of that table there that we created in the counts. And what you'll notice is that we don't see the NAs here. And this might be what you want. This might not be what you want. If you want to see the NAs, those missing values that we had included in the table, you just need to add on to additional argument here in the xtabs function, which is add NA. So that's add NA, where N and A are capitalized, equal to true. So just add in the NA values here, and let's rerun that. Okay, so now you see we have a row and a column that are corresponding to NA. So it's capturing all of the available possible cross tabulations that we might have there. Okay, so that's a little bit of a detour there. Now let's think about how we might display these using a data visualization approach. So given that we have categorical or ordinal variables, technically the most appropriate way to do this would be using a data visualization display such as a bar chart or a pie chart. And so let's start with the bar chart. And to do so, we are going to use, so let's note data visualization here. And so the bar chart that we're interested in is actually going to come from the lessr package. And so if you haven't ever used this package before, you'll want to use the install.packages function with lessr, and this is LESS lowercase, and then R capitalized. So lessr within quotation marks there. You would want to install this. I've recently installed this, so we're all good here, but you may need to do that. Then we'll use that library function with the name of the package lessr as the sole argument and run that second line there. Get some information about the package here that's presented in the console output. And now we're ready to use the bar chart function from lessr, which has a capital B and a capital C. So that's important that you get the case sensitivity there. And so specifically, let's do the jobsat1 variable. And so that'll be entered as our first argument here in the bar chart function. So jobsat1, comma, and then our second argument is going to be data equals and the name of the data frame where jobsat1 belongs. And so in this case, it belongs to survey data. And so go ahead and run this and take a look at your plot window here. And you should notice in your plot window that now we have this pretty nice visual here, along with percentage signs here that appear for each one of the levels of the jobsat1 variable. And if you look into the bar chart function, it's beyond the scope of this tutorial, but if you do a question mark for the help and type bar chart and run that, you'll see in the help menu, you'll get more information about all the different types of arguments that you can use here. Okay, but what if you want to, let's say, just as an example, you want to do the bar chart function we just did above here, and specifically, you would like to do what's called a trellis display. So we'll need to use what's called the by one equal argument here. And what you want to do is you want to trellis or do a lattice structure for the jobsat by, let's say, another variable that's categorical, like, for instance, location. So if we do by one is equal to location, and we add that as a third argument and click run, we now see in our output here, now we have by location, Boise, Portland, Seattle, the different, the jobsat1 responses by location. This might be a way to drill down or to segment if that's important for you. Now, if you want to do a stack bar graph, all you do is let's copy this line here and paste it right below. Just do, instead of by one, do by equals location and run that line. And here you have a stacked bar chart that you can see here. Another opportunity would be to use the pie chart function too. So let's say with the gender categorical or nominal variable, we'd like to use the pie chart instead. Well, this also comes from lessr. So we do capital P for pie and then chart with a capital C. And we actually can use the same argument structures we used before. So let's do gender with a capital G as the first argument. And then note the data frame using data equals, and the name of the data frame is survey data. And let's click run. And here, by default, it is going to be the donut shaped plot here. And if you look, do the question mark for help and pie chart, and run that line, what you'll see is that in terms of arguments, you can actually do a fill. So if you would like to do a whole fill, for instance, instead of having it be an empty, a donut shape, you could have the full traditional pie chart. There's actually the whole fill. You can fill the hole with a particular color and so forth. And so here's all the other different arguments that you can use. There's quite a few of them that are quite user-friendly in case you want to further specify or refine this data visualization. Okay, so the next thing that I want to show is, well, what do we do with our continuous variables, or so those that we're treating as interval or ratio measurement scales? So let's do continuous variables and interval or ratio measurement scales. So how do we describe these using descriptive statistics? Well, let's start with a visualization first, because if we want to start thinking about things like central tendency, indicators of central tendency like your mean, median, and mode, we need to start thinking about the shape of the distribution, and this will help us interpret and select which one of those is going to be the best indicator of the center of that distribution for a continuous variable. And so a histogram is a great way of doing that. It's kind of the classic approach for understanding and visualizing the shape of a distribution for a continuous variable that is of either interval or ratio measurement scale. So what we use first is the hist, H-I-S-T, all lowercase, function that comes standard with base R. So you don't need a specific package to use this. And so first we need to type in the name of our data frame, followed by the dollar symbol to indicate that now we need to attach the specific variable that we wish to actually visualize using this histogram. And let's say that it's the tenure underscore years variable that we're interested in. That is clearly a continuous variable here. It's numeric in nature. And if it's truly tenure, then 0 does have a meaningful, meaning the absence of tenure. In this case, it would be technically a ratio measurement scale. So let's do tenure underscore years. Make sure you get the spelling exactly right. And let's click run. Okay, so here we get a very bare bones histogram. If you want a more advanced histogram, I really recommend checking out another package from the Tidyverse, which is called ggplot2. It's where you can do most of the advanced data visualizations in R. Okay, so here we can see, well, this looks like a pretty normal distribution here. So in this case, probably the mean, median, and mode would all be about the same here. And so we could be comfortable using the mean as an indicator of central tendency here. Now, some of you, though, might actually prefer to use from that lessR packaging. And we've already accessed this, so I'm not going to run it again. But using that library function you could if you're opening this as a new session, is that we can use a function from lessR that's called the plot function with a capital P. And as the first argument, we can enter a continuous variable we're interested in visualizing. And so let's do tenure in years. So that tenure variable, and then the name of the data frame. And so the name of the data frame is survey data. And so this is going to give us what's called a VBS plot, or a violin box scatter plot. This is something that David Gerbing, who developed the lessR package, has been pioneering. And it's essentially a way of combining a violin plot with a box plot and with a scatter plot for a univariate variable here. And you'll see what this looks like in a second and why you might prefer this over a traditional histogram. So let's go ahead and run this, take a look at our output, and look what we find here. So note here that we have, here's the violin plot. It's that shaded area there. It's a mirror on either side, but you can get the shape of that normal distribution here. So it looks pretty normal here. And then we have our box plot here with the 75th percentile, the 25th percentile, and our whiskers. And if any of the dots here, which are individual cases, if they're beyond the whiskers, that's usually an indicator that they might be outliers. Okay? And so here we get a lot of information packed into a single plot. And in fact, if you look at the output, the text output for this, you will see that we get a lot of information here. The mean is already calculated for you for this variable, tenure in years, it's 8. Standard deviation, interquartile range, okay, so is also represented here of 4.82. We get the skew as well, so this is not very skewed here, it's pretty healthy range. And we get the lower whisker, the upper whisker, the median, and the maximum too. So the min and the max values too. Okay, so the longest employee to work here has been there almost 17 years. It didn't identify, based on standard convention, any potential outliers here for this variable. So this all looks good. So this is perhaps something you should consider using instead of the traditional histogram. It does pack a lot of information in here, both in terms of the text output and in terms of the actual visualization display that you get here. The other thing that you can do with this plot function is you can also do the trellis display, or in other words, the lattice structure. So let's copy that and add an additional argument here. So let's do the by one argument that we did above, and let's do this by location. So let's take a look at tenure in years by location and see if we can visually see any differences that we might want to explore using an inferential statistical analysis, potentially in the future, such as an ANOVA or something like that. Okay, so let's go ahead and run this line. And here you can see that we have the 3 different distributions displayed here for Seattle, Portland, and Boise for tenure. And so again, this is a really nice way to pack a lot of information into a limited amount of space here. Okay, so the last thing I want to show you is what if you want to run your mean, median, mode, and so forth on the variables in your data frame? Well, if you want to calculate the mean, for instance, and let's see, measures of central tendency here, you can use the mean function from base R, which is just mean, M-E-A-N, all lowercase, and then the name of the data frame, so survey data, $, and then the name of the variable of interest. So let's say we're interested in tenure in years. So we've just looked at this and we think that's going to be an appropriate indicator of central tendency. And then let's add this additional argument, na.rm equals true. And this is saying calculate it even if there's some missing values, so just ignore those missing values essentially. So remove the NAs. So if we click run here, you'll get that mean value down here in your console, your output. Now, if we copy and paste this exact same script below, turns out that you can keep the same argument structure and replace mean with SD, lowercase, and run that. You get the standard deviation. And you can replace it with min for minimum. And you will get the minimum value. We already saw this using the lessR package. We can also do it with max. And we get that. And let's try median. And we'll replace it with median, and we get the median value there. Okay, oh, and I'm forgetting one more, and that is range. Actually, I've mixed in here measures of central tendency and dispersion. So just so you know that the standard deviation, min, max, and range are measures of dispersion. So here, let's add dispersion. Okay, and so if we do range there, the last one, we get the range of tenure in years from 0.2 to 16.9. And then finally, I did neglect to put in variance here, which is just VAR, and then the same argument structure. And we can click that line and run. And so it's 12.76. And if you take the square root of that variance, you will get the standard deviation. Okay, so in fact, let's just go ahead and show how that works. Let's use the SQRT square root function here and enter the variance value there and click enter. And we get 3.5722. Well, a little bit of rounding error there, but you can see it's the same as the standard deviation calculation. Now, this was all quite a bit of lines of script just to look at one variable. Well, what if you want to, for instance, look at a bunch of measures or a bunch of these indicators across multiple variables? How do you save time? Well, we can actually use the install what's called the psych package. And so make sure it's all psych, lowercase, P-S-Y-C-H. So if you haven't installed this before, go ahead and do that. I've recently installed that, so I'm all good on that. And use the library function to access it, this package. And so let's click run on this line here. And then finally, there is a great function from the psych package called describe, all lowercase, and it's appropriately named. It's to provide descriptive statistics for your sample. And all you need to do within the describe function is the sole argument, enter the name of the data frame. Even if you have categorical variables and so forth, it'll kind of exclude those with NAs and NANs and so forth, but it'll give you the measures of central tendency and dispersion as well as skew and kurtosis for the remaining quantitative variables that you have in your data frame. So let's click run there. And here you see all the variables in your data frame. It'll even use it'll calculate these measures of central tendency even for variables that don't make sense, like survey ID. But here you get the mean, SD, the number of people, so you can get an idea if there's missing values somewhere. Also min, max, the range, skew, kurtosis, and that standard error is there as well. So that's a really efficient way to go about calculating a bunch of descriptive statistics all at once for continuous variables if they're on the interval or ratio measurement scale, or if you wish to treat Likert type scales that have been converted to numeric, as we've done in this case, as relatively continuous, you can interpret them in this way as well. So this wraps up the tutorial on descriptive statistics in R.